So you're going to see a little indicator of what's going on up here, whether I'm recording or not. Okay, are there any questions? Okay, so let's go ahead and jump over to I'll show you where you can find the slides. Let's see, we need to go to bookstore on the lab manual. Now I'm going to be publishing some digital versions of the lab packet. Your first dry labs are going to be quite extensive, and those are my dry labs that are going to replace the ones in the packet. Okay, so let's where is my application window? Okay, I need to do one thing. I had Canvas open and now I can't find it now. Here, let's go back to here.
Please begin digging in this spot.
Yes, understood.
The hell? Okay, this is, as you know, Canvas. And that is my lab coat, by the way. I'm going to talk about one of the things you can do in the lab is to do extra credit. And this is one of your extra credit projects is to decorate your lab coat. Okay, so where are the slides? You go to Files, Unit 1, Slides, and there'll be one for each subunit. So we're going to have 3 subunits in Unit 1. Usually we have just 2, but Unit 1 has got an extra one. Okay, and I'm going to be using these for the lecture. And so what I want you to do is if you go to here, this is a little explanation on how the course is put together, organizationally. Okay, there's going to be 4 units, 1 through 4, and an in-person test taken in the lab. So there's going to be no online tests, only in-person tests. So if you have Monday lab, you'll take your test on Monday. If you have Wednesday lab, you'll take it on Wednesday. And the Wednesday test will be slightly harder than the Monday test because you have 2 extra days to study. There'll be 4 dry labs, 1 per unit. Now, those are all due the day after the test, so you can use the dry labs to help you study for the test. Now, my revision of the dry labs is to help you study for the tests. There'll be lots of practice problems. We're going to have 8 wet labs, and those there will be an elaborate lab write-up for it. And for those of you who had me for 305, it's the same lab write-up. Okay. Does someone have a question? Okay, you're gonna have a research project, just like 305. Um, and the people that had me for 305, it's going to be the same research project. Basically, you're going to choose a topic of your interest, and you're going to create a poster and 1,000-word essay. Um, Over the summer, I had some really outstanding posters. I'm really impressed with quality of the work that my summer crew put together. Anyway, you're going to have the same research project. It will need to involve organic or biochemistry, though. Where in 305, it lets you do non-organic. Okay, let's go over the syllabus first. Okay, so there's two main areas on the syllabus that people are interested in. How to get a hold of me and how do I grade. Everything else is just boilerplate on the syllabus. That's why if you want the boilerplate, it's there. It's under files admin or under modules in Canvas. Okay, I do have Zoom office hours on Tuesday, Thursday. You need to let me know though. Um, if no one's let me know, I'm not going to have a Zoom session. You can either be private or the group. Okay, this is my email. You can get to me via Canvas or Outlook or Gmail. Any of those work. And this is what you're going to be using. Fergus T at this is the domain that I use. SCC for Sac City College, losrios.edu district. Okay. Lab is you're going to have lab either Monday or Wednesday. Now there's a challenge similar to what we had over the summer on the capacity of the labs. The labs can only hold 25, that includes me. So that means we can only have 24 students in there. Now, in the beginning, we have more than 48 students in the class because of I usually overload the class because there's a fair amount of drops in this class. And that means it'll come down to 48-ish. I'll be discussing that more in lab today and Wednesday. I'll give you, for those of you who are waiting to get in, we need to determine the no-shows of the enrolled people first. I can enroll 5 from each section. That means I'm going 10 over, so the class will be 58. And then the no-shows will be dropped. And then after a while, people, for lots of reasons, have to drop the class. Okay, now, so does that make sense in terms of getting hold of me? Okay, so now textbook wise, there are two textbook options. One is free, the other is not. This is an excellent book, Fundamentals of Organic, General Organic and Biochemistry. It's a quite good book. However, there's also a free one, and I've downloaded it, and I'll show you that where you can find that as well. It's 48 megabytes. That includes the 305 portion of it as well. So the free one is a 305/306. And it's not too bad. I think my lecture is going to be a little more detailed than that. But it's a good place to as a reference code. Okay, lab materials required. Safety goggles. They have to be chemically splash proof. That means if some liquid gets splashed onto your goggles, the liquid cannot seep in through the vent and touch your face. Okay, splash proof has vents, but they're special kind that don't allow liquids to pass through. Now, there are some cheaper goggles out there that Sac City does not approve. Um, so you're going to have to get approved ones. Now you can take at the stock room today and Wednesday. Excuse me. There's a barcode where you can automatically go to either Amazon or the student bookstore. Amazon's going to be cheaper, and the name of the goggles is UVEX Stealth. I've been using these for like 40 years. I have a pair that's probably 15 years old. I'm still using them. And then you need a lab coat. And a lab coat, as you saw mine, doesn't have to be white. I had a student that was a butcher. He brought one of his butcher's coats, and it was black. Okay, so we have lots of chats here. Let's see. Let me go check out the chats here first. If you rent a goggle, you can get a lab coat with it, free. And I'm not sure if you can rent just the lab coat. You probably can. To rent the goggles, it's $2 cash. So you might just throw a couple bills in your pack in case you forget your goggles or whatever. Sometimes they give it to you free, sometimes they don't. Okay, so let's go back to here. All right. Now this is a 5-unit class. That's why our lectures are 2 hours long. Now, frequently my lectures don't go full 2 hours. Okay, see. Okay, dry labs, you can make those up because those are just worksheets. Those are optionally, you can do them at home or you can do them in lab. And if you want to do them at school in lab, for lab goes over 24 students, you can go out to the lounge area and do it there. Oh, one other thing on shoes. You've got to have closed foot shoes. Okay, that means if I pour boiling water on your shoe, it won't hit your skin. So there's a lot of shoes out there that have holes in them for ventilation, and those are not allowed. So they've got to be a sturdy set of shoes. I'd suggest throwing a set into your car so you'll always have them. You can also store stuff in your lab drawer, like your lab coat, for example, and goggles. Okay. Okay, you're gonna have 4 tests, each worth 100 points. So there's raw points that I convert to a percentage. That's why there's always 100. I'm gonna have 4 of them, and when you take organic chemistry and biochemistry, every test is a final except for the first one because it relies upon past materials. So that's why I don't label anything as a final, but the 4th midterm will substitute for the final. So tests 2, 3, and 4 are all finals because they use all the data from previous units. And you're going to have 2 and your project is worth half a test, 50 points. You're going to have a lab waiver and a lab safety contract to upload to assignments and Canvas. And they're the same type of documents you uploaded in 305. Now, if on one of your tests, if you receive a C, D, or F, you may correct what you missed for half credit. So that means, for example, if you've got a 60 on the test, that is a low D. You can get 20 points back by correcting your mistakes. Okay. All right. So that's how to contact me and also grading. Okay. Are there any questions so far?
No.
Okay. How to best succeed in this class. Now, I've been uh, preaching this process for at least 20 years to my organic classes. All right. Since I record all lectures, and I'll show you where to find them in Canvas in a few minutes, um, um, including the slides. This is the process that I would suggest you take. I outlined this, I believe, on that email I sent out today. Anyway, you're going to go to the slides on Canvas under Files, Unit 1, and download the first one, Unit 1 subunit, which is alkanes, ALKNES. I'll show them to you that in a minute. Okay, and you're going to print it out, two per page, 2 pages per printed page. So that's big enough to see the detail, yet also won't use a ton of paper. You can print one per page if you want, and then watch the prior video on the topic. So what you would do, you would download the alkane slide, print it, and then watch the video on alkanes from last semester. Take notes on it. Then when I cover it in lecture, you can refine your notes. And that is a very effective way to study in this class. And then I'll show you all these steps here on where to find it in Canvas, etc. Now, wet labs. You're going to be doing a pre-lab before the lab starts. That is a detailed write-up. That's why you need a composition book for that, for your lab. And that's no binders, no wire, spiral notebooks, none of that. It has to be a comp book. And those are very cheap. If you want to spend a lot of money on your lab notebook, that's fine. I'm fine with any lab books, as long as there are permanent pages in there. And then I'm going to have a lecture on that, just that. Okay, when you're finished with the lab, now I have to initial the pre-lab whether you've done it or not. I also initial your lab when you've cleaned up. And you get points for that in terms of the lab write-ups. They're easy points, just so don't miss those. All wet labs, you have 1 week. Excuse me. You have 1 week to complete the write-up, which includes the pre-lab plus doing the lab and then post-lab. Then you're going to upload a scanned PDF file of that lab and have the you can upload it to the assignment that correlates to the wet lab. And this will make more sense once we get rolling. Okay, so that's the admin part of this lecture is like, what are we doing and some extra stuff. So any questions about admin? Okay, some of my students up at Sierra, and I only teach at Sac City now, but I used to teach at 2 schools. They would take the student learning objectives with ChatGPT and create worksheets. So here are the student learning outcomes. They're part of the syllabus. You can talk about the units are, each unit is going to have a student learning outcome. I think they need to be more detailed personally. I've written a lot of these when I used to work for the state, and these are in my opinion, too general. But anyway, you can run ChatGPT against these and it'll create worksheets, quizzes, and keys. Okay. All right. So since there are no questions, I'm going to go ahead and go on. And what I want to do is this is what the slides look like. Now, where is my share button? It is no longer around. Why is that? Okay, so let's go over to Canvas. And I'm under Files, and this is the free textbook. It's rather large, 50 megabytes, so it'll take a while to download, depending on your bandwidth. How to best succeed, that's the document I just went over. And if we go to Unit 1, here are the slides again. Here are worksheets. Now, these are going to be built into the dry labs that you're going to be doing. Also, miscellaneous is kind of a fun file. These two are videos that I did a long time ago. I used to own a photography business, and so I can do videos and edit them and all that stuff. Anyway, these are kind of fun to look at. Definitely play those. You will enjoy it. Okay. All right, so let's talk about lab-related stuff here. Here is the lab waiver. Now, probably I'm going to have some already photocopied in the lab on Monday, Wednesday. And so you can either download it or you can get one from lab. And also this Unit 1 Dry Labs, this is a PDF of all the worksheets that I just showed you that are covered in Unit 1. So if you look at it, it's 7 pages long or something like that. Also, you're going to have something called a flow chart, and that's where all the reactions are. So these are the reactions we're going to be learning about in Unit 1. Okay, so worksheet, just practice these guys. Now, I did not make all these up. Some of them I did, I had a colleague up in Washington where I taught at Tacoma Community College, and he and I did these together.
Excuse
These are
me, can
all,
I ask a question?
sure,
Are we allowed to like bring our iPads or anything inside of the lab? Because I know some of us use like digital note taking.
yeah,
We can
yeah,
bring them in? Okay, perfect.
absolutely, yeah.
Okay, I just wanted to make sure.
And one other thing regarding that, if you want to do your lab write-ups on your tablets, that's fine too.
Okay.
So I forgot to mention that when I was going over the requirements. So to reiterate what she's asking is, by all means, you can use your tablets, your laptops, anything like that in lecture or lab. When I eventually get excuse me, when I eventually get to the lab write-up, you're going to be able to do that on your electronic tablet as well, or on paper in the comp book. Either one's fine. Some people really like to do things electronically, and other people don't. So I have both options for you. Okay, so anyway, this is what the worksheets in dry labs are going to look like for Unit 1. And I'll have a Unit 2, 3, and 4 as well. Okay, so let's get out of that. And so here's the lab safety contract. Sign that, upload it. And this is the lab waiver. Download that, or I'll give it to you. Sign it and upload it. So if you look at assignments, here's the district lab waiver and the lab safety contract. Now, these are the easiest 22 points you'll have in this course. So definitely take advantage of it. Now, I have not put due dates down yet. It's on my little checkoff list. So I need to look at a calendar. Basically, it's a week after Wednesday is when it's due. So the Monday lab people will have 2 extra days to do the write-up on the lab. Most people finish it in one day, but anyway, I just automatically just say you have a week. Okay. Okay, so Hans, you asked where can we get the lab manual? Bookstore. I have a few of the files for the wet labs digitized because last summer they weren't available. So that was for 305. I had the same problem in 306 in the spring where I had to supply the digital files. So if we're in that same position, I'll make sure I sent the Zoom link, Taylor, to the waitlisted people as well. Um, I sent it to their non-school account. I have a roster, and I can send emails to anyone on the roster, including the waitlisted people. Now, if you're not on the waitlist, you didn't get the Zoom. So if this person, Taylor, is not on the waitlist, they haven't received any emails from me. So you can give her the Zoom session ID as well. Does that make sense? Okay,
Professor,
yeah,
Professor, just to clarify, we are only attending class for wet labs, correct?
no, dry labs and wet labs.
Okay,
Yeah,
so
all lectures are online.
correct.
All tests are in person in the lab. If you look at the lab schedule, you'll see when the tests are. Um, I also record all my videos, all my lectures. So if for some reason or other you cannot make the Zoom session, you can dial in the video, which I'll show you in a minute how to find them. And then it's a good way to study as well.
Awesome, thank you.
You're welcome. Okay, how to find out?
I'm sorry, I also had a question.
Yeah.
I was trying to look into like the district lab waiver to where to find that form. It doesn't show up when I click on that assignment.
Say that again? No.
The waiver doesn't show up when I try to click the district lab waiver assignment. Where do I find it?
So you're saying that if we go to
Okay. Okay, thank you.
where were you clicking?
I was clicking on the assignment itself, and I thought the file was supposed to show up on there.
Yeah, sometimes it does. It depends on the semester. They send things out where if you're in the class, excuse me, if you're enrolled in the class, um, it automatically goes through. And I don't know why they do it sometimes and other. So that I just supply it for everyone. That way it
Okay.
doesn't. Okay, so let me get out of that. Okay, I'm just going through here the chats. Natalie, what do you have from 305? Talking about goggles? Um, I need to see the goggles if they're from another class. Yes, you need to buy the lab materials. The coat will not be provided because you're going to have the option of decorating it.
Excuse me, I have a question about the dry labs in
Yeah.
person.
Mhm.
Do we have to, so obviously we have to dress accordingly, um, but do we have to bring our safety goggles? Do we have to wear that during dry lab?
No, only shoes.
Okay, thanks. Thank
And
you.
even if you have, for example, flip-flops, you can do the dry lab out in the lounge. In other words, as soon as you pass the threshold into the lab, you have to have proper shoes. No exceptions. When we have a wet lab, when glassware is out and chemicals are out, you've got to have goggles on.
Okay, thank you.
Now, regarding waitlisted people, I need to see um, on Wednesday, Monday, Wednesday labs, who the no-shows are. And that'll allow so many people in. So you're not going to get your um, ad permission numbers today.
Professor, for Wednesday, is it a dry lab?
Yes.
Okay,
Yeah, today and Wednesday both.
great.
And Miranda, what about ankles?
Yeah, I was wondering because my last lab, it was like I would wear pants, but sometimes they would be a little bit cut off on the ankles. I didn't know if it was super strict or what the case was.
No, you can have bare ankles in my class. That's fine.
Okay, sounds good. Thanks.
Now, the syllabus is from one of the other 306 instructors, um, Dr. Huang, and he's the lead instructor on this. And I based my syllabus on a version of his. He likes students to wear long pants. Um, the problem with that is sometimes it's hotter than heck in Sacramento. And in the summer, um, people were wearing shorts. As long as you have your lab coat on, you're fine.
Thank you.
One of the other issues, it's frequently freezing in the labs. You may not want to wear shorts. It's sometimes during dry labs, I'll actually put my lab coat on because I'm cold. It's all screwed up. Uh, the lecture halls are warm and the labs too warm, in my opinion. And then the labs are too cold. It's, I don't know who regulates temperature, and I can't change it either. Okay, can you share the slide? You can download the slides yourself. Does that make sense? Um, oh, this is a good question. Madeline, you don't have to print them if you're going to do digital notes. That's fine. I'm glad you're here. Um, Miranda, you can take notes on your electronic tablet, either in lab or in lecture. Yeah, tablets are fine. Okay, pre-labs. Pre-labs are only for wet labs. So we're going to have dry labs for a while. And our first wet lab is on alcohols. Um, so that's when you'll have a pre-lab due. Basically, the pre-labs are, I mean, the dry labs are basically worksheets. So there's no pre-lab involved with a worksheet. And yes, you need to get a lab manual. Destiny, yes. Let me make a note of that. I will send out the dry lab. Um, to the waitlisted people. I hadn't thought about that. Thank you for reminding me to do that. Okay, you need to buy the 306 lab manual. Chemistry 309 is a combination of 305 and 306. So the 306 part of 309 lab manual is part of the 306 lab manual. So there'll be stuff missing out of it. So Julia, the bookstore does not have a separate 306 lab manual?
No, it doesn't. It only has those two options that I put in the chat.
Well, you can get the dry labs off of Canvas. And I'll have to call the bookstore and ask why they haven't done that. We have brand new company that's taken over the bookstore. Um, and it could have been a slip up because of that. I know there's been a lot of problems with the changeover. I think Barnes and Noble took it over. But anyway, I'll have to check into that. Meanwhile, download the digital labs or the dry labs off of Canvas files. You don't have to print the worksheets. Yeah, PDF is fine. Okay, the whitelisted people, they're going to get a lab safety contract and a waiver when they come to lab. And you don't have to turn it in until you're enrolled. Okay, so Tiana, dry labs are worksheets. You may do those at home. This week, I would strongly suggest that you not do them at home, or at least attend lab today or Wednesday. And then from then on, you can do them at home. Yeah, another reason to show for lab is to sign the attendance sheet. Okay, and that's on the absences from lab, that's wet labs. Yes, we have lab today. Okay, Kyle, it says, what materials are needed for this week's lab? Um, you're gonna you have to have some way to download the dry lab digitally. That's a tablet or uh, a laptop. You need a pencil. You don't need a calculator at all. Um, and the material in the worksheets are based on lecture materials. So if I haven't covered that in lecture and there and the dry lab is covering, for example, alkenes, which I'm going to do next, the next subunit, just wait till I cover it in lecture because they're not due until the test. So you got lots of time to do the wet lab or the dry labs.
Professor, do you have to approve for people to be able to access the meeting?
What meeting? The one we're having now?
Yes.
No, I sent out, everyone on the wait list got an email, actually got about 3 emails from me on the Zoom session ID. And I told them they have to attend because if I'm giving out permission numbers and they're not there, they won't get one.
Okay, Gabriel is currently trying to join, but she's not able to access, and she's asking me to see if you can accept her, but I'm letting her know. I gave her the updated permission number. Hopefully she can get in.
Yeah, Zoom actually canceled my prior one. Um, I modified it because it was Monday through Thursday because of 305 summer class, and I changed it to Monday, Wednesday. Then they canceled it, so I had to schedule another Zoom. That's why the Zoom's ID number changed.
Okay.
So yeah, did she have the old number? Curiously,
I believe so, but I just sent her the current one, so hopefully she's able to access it with that one.
the new one's actually easy to remember. It's 30. Let's see, 82 82 032 1960. It's really easy to remember. The Los Rios website is down. Is it still down?
Yeah, the e-service website is still down.
Hmm. Usually they tell me this stuff. Um, yes, today's lab is for Monday lab people only. Wednesday's lab is for Wednesday's lab. Okay, so if I answered all the chat questions. Okay, these are the problem is that the name's too long. These are some of the dry labs. They're basically, this is a one on sunscreen. They they give you a background which covers, and then they ask you questions about it. Okay, so let's go over to modules. Still in Canvas. And here's a video on the lab write-up. I'm going to be going over that either Wednesday or Monday. And we have a Labor Day holiday coming up too. It's listed on your, let's see, it is the 7th. So that's 2 weeks from today. Okay, so here are Unit 1 videos from past semesters. So you can view any of these. And the way I do videos is when I'm done today, I'm going to stop the recording and it'll render whatever's been shown on my screen to an MP4 file. An MP4 file is a video file. Then I take and copy that to YouTube. And I have a standardized way I name the videos. I say what unit it is, the subject, and the date. So we're doing alkanes today. So if you click on this, it's going to go to a Canvas page. And when you click on the link, it's going to go to the YouTube link. Now, the other way to access the videos is from Pages. And the third way is for the waitlisted people, you're going to go on to um, um, YouTube under Tom Ferguson Chemistry. And that's where all my videos are stored, plus some other ones that have Ferguson in the name or whatever, but you'll see the videos there. And you can just do a search on alkanes and then the date um, today, and you'll see it there. So 3 ways to access videos: modules, Pages, and YouTube. Okay, these videos are only from Sac City. None of these are from Tacoma. When I left Washington State, Tacoma Community Colleges took my videos. They said they were the property of Tacoma Community College. Wouldn't let me take them. So now we do everything on YouTube, and they're then mine. Okay, so any questions about how to find the videos, what's under modules? Now here is the red dot that says I'm recording. So if you don't see that red dot under screen sharing, make sure that you tell me. Okay, so let's. This really bugs me about the bookstore not having our lab manual. I take attendance in the labs. Yeah, so Brianna, would you send me an email regarding posting the dry labs for the waitlisted people? I wrote it down, but just in case. Okay, so let's go ahead and start here. Okay. Okay, so I use OneNote for doing my lectures. OneNote is a Microsoft program that comes with Office, and it allows me, I have a tablet that displays whatever's on my laptop screen displays on the tablet, and I can write on the tablet. So, but if you want to use OneNote, it's a very nice program. I've been using it for many years, and I've grown very accustomed to it. There are others programs as well. Um, Usually tablets, um, you can download it PDF and write on the tablet as well without having a separate tablet like my laptop here. Okay, so this is the first slide of the alkane slides. Now again, you can find those in files. Unit 1, slides. Someone have a question? Okay, so there are many types of chemistry. You've heard of organic probably. 305 is considered an inorganic class.
Well,
Excuse me. There's also physical chemistry. That's things like quantum mechanics and thermodynamics and things like that. Um, there's also nuclear chemistries. There's quite a few different chemistries. Organic chemistry is the chemistry of carbon compounds, and that includes carbon, hydrogen, oxygen. Those are the most common elements in organic chemistry study. But there's also sulfur is included. Um, did someone have a question? Okay, someone needs to mute their microphone. And nitrogen. But these top three are the most common. Organic compounds, not including biochemical organic compounds, there's tons and tons more. This slide was created probably 20 years ago, 25 years ago. And so they're creating organic molecules like all the time. So um, it's probably like 60 million by now, as opposed to a small number of inorganic compounds. The properties, when you compare organic versus inorganic, now there are exceptions to all these. There are exceptions to all these. Okay. The bonding is covalent as opposed to ionic. An example of an ionic compound would be table salt, sodium chloride. An example of an organic compound would be like butane lighters, covalent versus ionic. The forces between molecules are generally weak. With ionic, they're generally strong. Now we're going to be studying IMFs a lot in this class. Every test is going to have three parts, without exceptions: intermolecular forces, naming, and reactions. Every single test. Okay, this varies. What they're saying here is that organic compounds can be anything, a gas, a liquid, or a solid. Um, Flammability. Inorganic stuff is usually non-flammable. It doesn't burn. Um, Organic compounds frequently will burn. Frequently. Okay. Is it soluble in water? Often, no, or it's very low solubility. Ionic compounds usually are very soluble because water is very polar. Ionic compounds are very polar as well, so like dissolves like. So that means the polar organic compound, excuse me, the polar inorganic compounds were quite comfortable in water. Ionic compounds usually are inorganic. Frequently, they conduct electricity. This requires an ion. If the inorganic compound is not an ion, it can't conduct electricity either. And this, there are a lot of fast, organic compounds. Like dynamite, for example, is an organic compound. TNT is trinitrotoluene, and that reacts obviously extremely fast. So a lot of things are slow and organic, but there's also a lot of very, very fast um, reactions. Okay. Now, we're going to be using something called line drawings. And line drawings are quick ways of representing an organic compound or a biochemical compound. For example, if we have propane, which is 3 carbons, that's a lot of H's to write, a lot. So instead of that, we're going to represent the CH3, CH2, CH3 with that. Now, this is called a line drawing. Now, the good news on the line drawing is you have to understand that carbon that carbon has 4 bonds. Oxygen has 2. Hydrogen has 1. Nitrogen has 3. Okay. So when you're doing a line drawing, there are 3 parts: the beginning, the end, and the middle. So this is the beginning, or that's the beginning, depending which way you're going. Each one of these has a carbon. Now we have 1, 2, 3 carbons in propane. This is propane. You're going to know these backwards and forwards. Sometimes you don't have a middle carbon. In other words, it may look like that. So, but it does have a beginning and an end. So this would, what I just drew would be this. That's 3. No middle carbon. Now, a middle carbon has a kink in it. If it has two kinks, that means it's two carbons. For example, we can have a beginning, end, kink, kink. So carbon, 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 carbon. Oxygen can attach to an organic molecule. Two ways. So say we have, that is the backbone, the carbon backbone. Say we have an oxygen that needs to be attached, something like that. Let's see. Sorry. No, let's make it C2H6. Okay, so this is C2, two carbons, beginning, end, and we have an oxygen on there. So that's going to look like this. So two carbons, no kinks, because there's no middle carbons. And then we have an O. Oxygen has two bonds now. I'm drawing Lewis dot structures. So this is one bond here. And that's the other bond. Now, oxygen can have two singletons or one double. So we're going to use, this is called ethanol. Ethanol is a drinking alcohol. There's a lot of alcohols in the world. Millions of them, different ones. Cholesterol, alcohol. Okay, so we're not going to be using this notation at all. We're going to be using that notation. Now, some of these slides don't use line drawings, except for biochemistry. Biochemists only use line drawings. For example, glucose. This is what glucose looks like. This is a unit 2 chemical. Okay, you won't see glucose written like this at all with the H's in there. But this is a carbon, a kink. But notice there's only 3 bonds that carbon has. So the other bond is an H right there. But they don't write the H. It's assumed that the reader understands that carbon has 4 bonds. Also, there's no line there either. Because again, the assumption is the reader understands oxygen has 2 bonds. So if there's no line there, that means there is a line there because there's no way oxygen can only have 1 bond, it has to have 2. Hydrogen has 1 bond. By the way, this will be one of the structures you're going to have to know for Unit 2. Okay, so does this line drawing, now all the dry labs are set up for line drawings. So you'll get really used to it. A lot of my students, the midway through 306, they'll say, boy, I'm sure glad we're doing line drawings instead of all those H's. Up in Washington, Tacoma, I used to teach an introductory class to organic. And I didn't do line drawings at all there. I did the H's and everything. I hated doing all the H's. It drove me crazy. But there was a very short section on organic chemistry, so I couldn't teach them line drawings because it wouldn't be applicable. But okay. All right. Now, there's something called an isomer. Um, okay, so we have a formula here. We can write two Lewis structures that are legal with that formula. One is like this. So that's carbon, carbon, carbon. You can also write it like this. So we have 1, 2, 3, 1, 2, 3, 4. Yeah, it should be 4. Okay, and then 1, 2, 3, 4 as well. Now, both those are legal Lewis structures for this formula. So these are called isomers because they both accurately represent C4H8O. So isomers have same number of carbons, hydrogens, and other O's, S's, or N's, or whatever. And they can be represented by legal Lewis structures. Now, our subunit 3 is on alcohols and ethers. So you're going to be learning these guys in intimate detail. Okay, are we hanging in there okay, you guys? Is this making sense? This is probably the first time you're seeing any of this. If it is, it's going to be, you just have to do lots of problems. That's why I provided lots of worksheets. Okay. Besides the carbons, there's something called a functional group. The functional group gives the carbons, it's called classes or ways of reacting. For example, this is an alcohol. In other words, you have a carbon backbone here. And here is a aldehyde with some carbons hanging off of that. This OH is different than that OH. And this carbon and oxygen is different yet. So these three compounds react very differently because of the functional group. If the functional group is different, the reactions are different. In fact, if we look at um, if we look at okay, so these are all the reactions of Unit 1. And by the way, I'm going to give you one of these for the test. You don't have to memorize it. You're going to use it a tremendous amount, though. Okay, for alkanes, that's what we're talking about right now. The reactions for alkanes are only three. One is to create a haloalkane. That means an alkane with a halogen on it. And usually there's a mix. We're going to talk about what that means, a mix, and a spark or combustion, which turns it into carbon dioxide and water. Those are the only two reactions. There's another reaction that's biochemical only. It's an oxidation reaction. Okay, and the functional group in alkanes is just an H. Alkenes have a double bond, so they have many more reactions, 4 of them, 5 of them if you count combustion. Alcohols have 1, 2, 3, 4, 5, 6, 7, 8 reactions, and 9 if you count this aldehyde to an acid. So what distinguishes each one of these is the functional group. The functional group determines the reaction type. So alcohols and aldehydes act differently. Now, one of the many things you're going to learn in this class is related to the law. For example, if you're stopped for a suspected DUI, they will give you a breathalyzer if you agree to it. The breathalyzer takes the alcohol, the drinking alcohol, and converts it to an aldehyde. And that aldehyde conversion gives off a color. And the intensity of the color determines the percent alcohol in your blood, or actually in your breath, which is the same as your blood. That's how your blood gets rid of the alcohols in your lungs. Also, when you drink alcohol, your liver does the same thing. Your liver oxidizes the alcohol to an aldehyde, and then it oxidizes the aldehyde to an acid, acetic acid specifically, and then you urinate that out. So that's how your body detoxifies alcohol. There's a specific enzyme called alcohol dehydrogenase and aldehyde dehydrogenase that detoxifies that alcohol in your liver. Now, if you drink too much, there's not enough enzyme to go around. So it has to stick around a lot longer. That's why if you drink too much alcohol, it takes a while to get out of your system. So anyway, functional groups, they're a big deal. Now, some people say that the functional group for alkanes is a CH. And some people say there is no functional group. So it depends on what book you're reading. Okay, so I already mentioned we're going to be doing line drawings. Not these guys. And we'll rarely use the formulas, but never with all the H's in it. Okay, you've probably heard of the term hydrocarbon. A hydrocarbon only contains carbon and hydrogen, no oxygens, and they're all single bonds if it's an alkane, and those are also called saturated. Now, you've heard of saturation as it refers to fats. You can have a saturated fat or an unsaturated fat. A saturated fat is an alkane, and those are considered unhealthy fats. An unsaturated fat would be something that has double bonds in it, or an alkene. Now, we're not covering alkynes in this class, as this is a allied health strand we're on. There are no triple bonds in our bodies, only double and single bonds. Okay, so we're studying, this is subunit 1, subunit 2, and then the third one is alcohols. So if this had other carbons attached, but so saturated has no double bonds. Alkenes have double bond and single bonds. Alkenes have triple, double, and single. And then something called aromatics, which has a combination of single and double, but they're alternating. Single, double, single, double, single, double. And that I'm going to cover the alkenes and aromatics I'll cover on Wednesday. Okay, so we have propane, which looks like this. Ethane looks like this. And methane looks like this, with just a dot. Methane has one carbon, so that's what the one carbon is. Ethane has two carbons. Carbon, carbon. Propane has three carbons. Carbon, carbon, carbon. Now there's something called branching. What branching is, has to do with something called a carbon backbone. Now, I always do it in yellow. So the first step in naming an organic compound is, what's the backbone? So the backbone is the longest carbon chain where pencil is not raised. Okay, so what do I mean by that? Okay, so let me go over and grab a yellow highlighter. All right, so on the one on the left, I can cover all the carbons without lifting my stylus. If I have to lift my stylus to cover a carbon, then that carbon is not on the backbone. So those are called branches. So notice this has 5 carbons on the left, 5 carbons on the right, but not the same molecule at all. But they have the same number of carbons. One's branched, one's not. Now, so frequently they'll abbreviate normal to N, italicized N. Like this would be N-pentane, because there are 5 carbons. This would be dimethylpropane. And we're going to get into naming in a little while. But the bottom line is, because the carbon count is the same, doesn't mean they're the same molecule. One could be branched, one could be not. Even if they're both branched, they still may be not the same molecule. For example, 5 carbons, And so that's the backbone. And there's one carbon not on the backbone, so that would be the branch. One carbon branch. It's called a methyl. And because we have two of them in this case, it becomes dimethyl. This would be methyl butane. And we'll get to how to do that in a second. There's a dash. So that's methylbutane, dimethyl propane, and N-pentane. All have 5 carbons, different molecules totally. Okay, so this has got 4 carbons in the backbone. And then this has 2 versions of the backbone. Let's use a different color. That could be a backbone also. Either way, it has 1 branch. Both those are legal backbone designations. Now, I'd recommend use a highlighter to do the backbone. And anything that's not highlighted is a branch. Now, there's one property of single bonds as opposed to double bonds. Single bonds are free to rotate. So here we have a carbon-carbon bond here. This guy here, carbon-carbon, single bond, and that can rotate. So this thing here can rotate. Now, interestingly, we have 2 ways to represent that. Actually, 3 ways. We can have the methyl group straight up. We can have the methyl group going to the left, or we can do another one where the methyl group is going to the right. So one of them is more stable than the other. Now these two are the same. Okay, so is the left one more stable or the right one more stable? Now, one thing about the universe, stability rules. The universe doesn't believe in having unstable things. Everything tries to go from unstable to stable all the time. So one of these is more stable than the other. So it'll spend more time in the stable state than the unstable state. So this is more stable than this one. So the molecule, in this case, 4 carbons, 1, 2, 3, 4, is going to spend some time where the methyl groups are farthest apart. And this is called steric hindrance. Steric hindrance is a very important concept in organic and biochemistry, particularly biochemistry. What's going on here is this methyl group is getting in the way of that one. So how do we fix it? We just twist it so that it's not as close. Okay, and we're going to see this time and time again. So single bonds can move around. So we took this here and twisted this, where we get that. So in this case, this is more stable than this one. Now, this comes into play a lot in biochemistry because in biochemistry, you have something called an enzyme, and an enzyme, we're going to do a lot of work on enzymes in here. Basically, though, the enzymes have something called an active site, and that active site is a certain configuration, and only certain, call them substrates, can fit into that. If the molecule is different, it won't fit in. Even though its number of carbons, even though the number of hydrogens are the same, doesn't work. Let me give you an example. Left hand, say it's still like this. Left hand, right hand. 4 fingers, 1 thumb, 1 palm. Are they the same molecule? No. They're mirror images of one another. This is a big deal. Back in the 60s, there was a horrendous teratogen outbreak in both Europe and the United States from a chemical called thalidomide. Thalidomide was given to pregnant women in their first trimester for nausea. However, when they gave it to them, they gave them the mixture of this one. It's a mirror image. That one caused birth defects. That's what a teratogen is. Huge problem. Monosodium glutamate, MSG. MSG comes 2 ways, the D and the L form. When you buy it at the store, it's got both of them in it. Some people are allergic to the D form. The natural one is the L form. We'll talk about that when we get into amino acids. So that left and right thing is a big deal, particularly in biochemistry. Big deal. Carbohydrates exist in D and L forms also. The common one in the body is the D form, not the L form. Okay, let's go on here. See what I do. Share. Okay. So here we have four different molecules, 5 carbons all the way around. And these two over here, these two, this one and this one, are the same molecule. Because remember, single bonds can twist, not a problem. So we can take this one and twist it into this one on the right. So the left and right top are the same molecule. Notice there's no branches because we're able to take our highlighter and cover it without lifting it on the left one and the right one. So these would be called N for normal, pentane. N, pentane. Now the bottom two also have 5 carbons. But we can lift the pen to get to all 5. That means the backbone is not 5, it's something less than 5. So here we go. And to get to this one, I've got to lift my stylus off the tablet to get to this one up here. Now, if we used a different color, like this orange, it's the same deal. So there are 2 ways to represent the backbone in this bottom left one. Yellow or orange, I guess, or brown. It doesn't matter which one you choose. So this has 1 branch, and that branch is a methyl branch. So this would be 4 carbon backbone. That's called butane. 1 methyl on carbon number 2. So 2-methyl butane. This one over here got a 4 carbon backbone as well. 1, 2, 3, 4. With let's so we can go like this. With this one over methyl over here being the branch. So this would be also 2-methyl butane. Both these are normal because the backbone doesn't contain any branches. You can draw the backbone without lifting the stylus. These 2 are branched because you got to lift the stylus to cover all 5 carbons. Okay. This you need to know. This is getting into naming. So and we're not going to be using these. These are more complex and it's really doesn't fit. Oops. We're only going to be using this one up here. So the longest branch can be 3 carbons. That pages just exit out. They include 4 carbon branches, and we don't cover those very often, so there's no point in learning that. You do need to learn this one, though. So these are branches. branch names. Let's see, let me rename this here. These are branch structures. And these are the branch names. So if the structure has one carbon as a branch, it's called methyl. If it has two, it's called ethyl. If it has three, it depends. If it's a straight chain, three, it's called N-propyl. If it's got a branch in it, it's called isopropyl. Propyl means there are three carbons, but they're not attached the same. Okay, methyl is attached to the backbone. Ethyl is attached on one side or the other to the backbone. N-propyl is attached on the end, or this end. Isopropyl is only attached in this middle one. Can also have non-carbon branches. We're not doing any fluoro because there's no fluoro occurring naturally in the body unless you use, well, it doesn't occur naturally, certainly. And mainly we're going to be talking about chloro, but there's also bromo. There's a lot of amines in the body. So these are the common branches that are not carbon: chloro, bromo, amino. So naming alkanes. This is naming all organic compounds. And we're using something called the IUPAC, International Union of Pure and Applied Chemists, versus common name. So IUPAC name, common name. Now, IUPAC names are nice because it doesn't matter what country you're in, the IUPAC name will be the same. So dihydrogen monoxide in United States and Russia is the same. Water in the United States versus water in Russia, the common name, is not the same. But IUPAC names are the same. That's why they're called International Union. Okay, so we're learning the IUPAC name here. So there's three parts to all IUPAC names. This is the functional group or the functional class. This is carbons in the longest carbon chain, which is called the backbone. And then if we have a branch, so if there's no branches, then we're not going to use a prefix. So that's only if there's a branch. And you need to know these guys for the backbone. And you're going to add an ane at the end for the functional group of alkanes. Okay, so we need to know this here. Okay, so all right, step number one is identify the backbone. Now there's two backbones here that are legal. Actually, there are three, but now whenever you number the backbone, we have to number it because we need to determine if there are any branches, what carbon number the branch is on. That means you can start numbering from the left or the right. So I'm going to number in black here, starting on the right, and I'm going to do it in red from the left. So this is carbon 1, 2, 3, 4, 5. Okay. So in line drawing wise, this is what it's going to look like. Let me Okay, so we have a yellow backbone. This up here is a branch. Now, we can also start it up here on the yellow backbone. So both of them work. Okay, numbering wise though, there's two numbering systems we're going to use here. One in red, one in blue. So let's name them. And all I've done is the red starts on the right numbering, the blue starts on the left numbering. So I'm going to write, if I was to write the name of this pentane down, okay, it's got a branch, and the branch is either going to be on carbon 2 or carbon 4. Depends on the numbering system. So let's name the red one first. That's going to be 2-methyl pentane using the red numbering system. If we use the blue numbering system, it would be 4-methyl pentane. Question is which is right? Well, let's look at the numbering system. Okay, there's no number here. Sometimes there's a number here, particularly with the next next subunit we talk about alkenes and alcohols. There's going to be another number here in the middle. But with alkanes, there's no number there. Okay, so we have a 4-methyl and a 2-methyl. Now, which is smaller? This is a tough one. Well, the 2 smaller, right? 2 smaller than 4. So we always go with the smaller one. So the correct name is 2-methyl pentane. So we have 3 parts. So branch, backbone, functional group. Now, this here, because we had a branch, that'll be the third part. If there was no branch up there, the top, it would just be pentane. Backbone is 5. It's 5 carbons. Functional group is alkanes. So that's an ANE, functional group name. And then we have a branch on carbon number 2 of the red. Okay, so when we're in this subunit, alkanes, and the next one, alkenes, you need to number 2 ways, because a lot of people always start numbering from the left. Well, in this case, if we numbered from the left in blue, we would have ended up with the 4-methyl. Numbering from the right, we end up with the 2-methyl. So you have to number both ways and see which one gives you the lower branch number. let's see. Okay, let's look at this guy here. Does this make sense?
Can you talk a little about when a dash is needed?
Yeah, I like to put dashes in there just so that it's all connected. See, if I didn't have a dash here, because I have a YL, we know that's a branch. Methyl, it's one carbon branch. That's right here. But it's optional. I always put it in just because I think it makes it more complete. On this one here, you definitely need a dash on the two. They always dash that. Between the 2-methyl and the pentane, though, I've seen it with and without the dash. I like to put it in just so it's all complete. Was that enough of an explanation?
Yes, sir, thank you.
Okay. All right, let's look at this guy. Now, this is going to be more complicated for two reasons. One, we've got more branches, and we have different types of branches. Excuse me. Okay, so if I was to do the line drawing, this is notes from last time. And let's do this in blue. Okay, so lettering from the left on the top one. Let's number from the right on the bottom one. And let's do it in blue. Okay, so step one is highlight the backbone. That's 7 carbons long. Okay, so that is heptane. And it's heptane because it's a alkane. Okay, now we've got branches. We've got 3 branches. We've got one here, here, and here. Now, methyl isopropyl. So first of all, which numbering system are we going to use? Top or bottom? Well, the top one, the branches numbers are going to be smaller because this is going to be a 2, 3, 4 branches. And this one's going to be a 4, 5, 6. So the carbon numbers for the branches on the blue are higher than the one in the red. So we're only going to use the one in the red. So let's name it now. Okay. So actually I need more room. Let's do it right down here. Okay. We've got an isopropyl. This is 3 carbons, 1 carbon, 1 carbon. So the 1 carbons are methyl. That's the most common branch. This one is the isopropyl. Now with 3 carbons, 1, 2, 3, it depends on where it attaches. With isopropyl, it attaches in the middle as opposed to the end. If it attaches in the middle, it's called isopropyl. Think of the snake's tongue. If you look at it looking upward, looks like a snake's tongue. The forked tongue of the snake. Okay, so we've got 4 isopropyl, and we've got okay, so which do we put first, the isopropyl or the methyl? Notice I didn't say dimethyl, methyl. Well, we're going to alphabetize them. We have I and M. I comes before M, so the isopropyl comes first. So it's going to be 4 isopropyl, 2, 3 dimethyl heptane. So if you have iso, it's not a P, it's an I. If you have any of the mono, di, tri, etc. methyls, it's always M for methyl. Okay, now we're going to end this at 2 today. Now you can also, I'm going to pick up tomorrow right here. You can also have cyclic alkanes as well. So we're going to be naming cyclic ones tomorrow. Numbering is a slightly different with cyclic ones. Okay, what do you guys think?
When you say tomorrow, do you mean Wednesday?
Say again?
When you say tomorrow, do you mean Wednesday?
I'm sorry, Wednesday, yeah.
Thank you.
I'm used to my summer schedule.
This is great. Thanks.
Yeah, Wednesday. So, isn't this different than 305? Slides are on Canvas. I put them, if you go to Canvas files, and you go down to Unit 1, under Slides, that's where all the slides are. So we're on alkanes. That chapter refers to the purchase textbook, not the free one.
Could you show us where we find the free textbook again?
Yeah. You go to Files, at the bottom here.
Gotcha. Thank you so much.
And don't forget that's 305 and 306. So you're going to skip through the 305 stuff about halfway through, and then look for alkanes. That'll be the first chapter.
All right. Thank you.
Okay, let's see if I answered everything.
Professor,
Yeah,
will we be using calculators for this class?
no.
Okay, great.
Let's, how do you pronounce your name? Is it just Janess?
Hi, it's Janess. Yeah. I wanted to know if there's a digital version of the lab manual or
Well, I
if there's
think we're
also
gonna
a
end,
physical version.
um, I think we're, because the bookstore isn't carrying the 306 manual. Um, I'll supply you with the digital parts.
Okay. Thank you.
Natalie, I feel a bit confused. Is that normal? Yes. Will we eventually get this? Yes. The it's just so different. It if you took 420, which is the year-long organic chemistry class, um, it's even more confusing in the beginning because you do all these mechanisms and stuff. So I'm relieving you of that. Yes, we have a lab today, 3 o'clock. Now I'm still at my house, so I have to drive there. That's why we have to end the lecture at 2.
Hi, Professor. This is Aisha Taylor. I missed part of the first half of the lecture. I wasn't able to log in. I just wanted to make sure that my attendance was accounted for.
I'm taking attendance in lab anyway. There's a way you can do
Did I mute
attendance
it?
on Zoom, but you have to go to the main website and you have to log in to that, and it's long involved. It's just easier to do it in lab. And then because you came in late, just look at the video. All right, why don't we? Okay, so I'm going to, are there any other questions? Otherwise, I'm going to sign off and upload this and get it. Uh,
Professor,
yeah,
since I'm enrolled for the lab on Wednesday, I wouldn't need to show up until Wednesday, correct?
correct.
Okay, cool.
Okay, I'm going to go ahead and stop the recording.